Hi champ, how are you doing? Welcome into another amazing session of mathematics and I'm your master teacher Shivam Gupta. So champ, in this class of surface area and volume, we are going to discuss a very special geometry which is the frustum of a cone. So champ, a topic which is very important for the exam, at the same time a topic from which many students get scared. So make sure that we are preparing, you are making the notes of this topic also. So let's get start, champ. So in this class, we will be looking at that what is the frustum, then how we can find the volume, surface area and the slant height of the frustum of a cone. So let's get start with the introduction. So let's say, champ, we have the cone, right? Now, if we are taking a plane such that the alignment of the plane is parallel to the base of the cone. If alignment of the plane is parallel to the base of the cone and we are cutting the cone from that plane, then we will get two different geometry. The upper one will be the cone and the lower part will be known as the frustum of a cone. So first of all, it is very important to understand that what is exactly frustum looks like. So make sure that you know this diagram so that you can solve the question easily also. So now, champ, the word frustum is a Latin word, the meaning of which is piece cut off. And we have seen this also, right? When we are cutting the cone in a particular manner, then we are getting a frustum. Yes? Now, champ, one very important question to think about. That how we can find the volume of the frustum. How we can find the volume of frustum? Do we have any formula for that? So champ, yes, you are correct. We can find by volume of the whole cone minus volume of the cutout cone. Then we will get the volume of frustum. So let's see how we can do it. So let's say, champ, this diagram, and a diagram is very important. We can see that we have a bigger cone and we have a smaller cone with a separate height. H1 is the height of the whole cone. H2 is the height of a smaller cone. And H is the height of the frustum of the cone. Same with the slant height. And R1 is the radius of bigger cone. And R2 is the radius of smaller cone. So now let's get start. So first of all, we can see the triangle ANE and triangle AMC. Both the triangles are similar triangle by double A criteria. Now we know that if two triangles are similar, then the ratio of their corresponding side will be equal. Yes, now we know that AN is H2, but AM is H1, same, NE is my R2 and MC is my R1. So from here, we can find the relation between H and R. Now, champ, what we can do, from the diagram, we can see that H2, we don't need the height H2. We want H1 and H. So, champ, let's say we have the height H2. H2 can be written as H1 minus H. Simple substitute over here. So now from here, if we cross multiply, we will get the value of H1 in the form of H. Or we can say that we will get the relation between the height of the bigger cone, the height of the frustum, and the two different radii of the frustum also. Now, champ, we know that volume of the frustum will be what? Volume of larger cone minus volume of smaller cone. Formula is what? 1 by 3 pi r square h, right? So now, champ, the larger cone 1 by 3 pi r1 square, then h1. Same for the smaller one with the radius r2 and height h2. But we want the height h, not h2. So what we can do over here, champ? We can take 1 by 3 pi common. Then after putting the value of h2, h1 minus h, because we don't want h2, right? Now if we will take the common, we will simplify. After putting the value of h1 in the form of h, we will get the very simple relation over here. Now from both the terms, we can take h common. But one more thing, look it over here. If I will factorize this, I can factorize this by a square minus b square formula. After factorization, we will get 2 factor. So this factor will get cancelled out and we will be left with this only. And I can take h also common. So after taking h common, we will get very simple formula. And this is our final formula for the volume of the frustum. Very simple formula. 1 by 3 pi h. Now instead of r square, there will be r1 square plus r2 square plus r1 r2. I hope it is clear. So don't forget to write the formula in your notebook. Now Chem, let's move on the surface area of frustum of a cone. So let's see. We know that again the triangle ANE and ANC are similar triangle with the help of double A criteria. So again the ratio of the corresponding side will be equal. So we can write AE upon AC equal to NE upon MC. And why we are considering AE and AC? Because we know that in the surface area of the cone, we have to use the slant height. And that is why we are considering the slant height over here. So now champ, again from here we can get the relation, but we don't want L2. So we can replace L2Y, L1 minus L, and the same relation we will get just like the volume case. So from here, I will getting the relation between R1, R2, L1 and L champ. So we can write L1 equal to R1 L upon R1 minus R2. Now again the same formula. The curved surface area of the frustum will be CSA of larger cone minus CSA of smaller cone. The CSA of cone is what? Pi R into L. That is why for the larger cone, pi R1 L1 minus pi R2 L2. Now I know that L2 is what? L1 minus L. So we can write it over here, and when we will be putting the value of L1 over here, we will get the formula of curved surface area. Simple substitute the value of L1, we will get this relation. One factor is getting cancelled out, and we are getting the final very simple formula, pi R1 plus R2 into L. So now we have the formula of CSA of frustum also. So now we talk about the total surface area of frustum. We know that if we have the CSA of any geometry, then in order to find the TSA of the same geometry, we have to add the area of the bottom surface and area of the top surface. The same thing we are doing over here. So CSA of the frustum plus area of the bottom face plus area of the top face. Area is what? Circular one. So area of the top and bottom will be what? Pi R1 square plus pi R2 square. Simply add them, you will get the formula of TSA of frustum also. I hope it is clear. Excellent, very good. So now champ, let's see the relation of slant height of a frustum of a cone also. So champ, the slant height of the frustum is L. Yes. So we can see if we will draw the perpendicular from the point E on the base of the larger cone, we are getting a right angle triangle ELC, where the hypotenuse is the slant height of the frustum, the height is the height of the frustum, and the radii is the LC. LC is what? R1 minus R2. We can apply the Pythagorean formula EC square equal to EL square plus LC square. EC is what? The slant height of the frustum, EL is the height of the frustum, and LC is the R1 minus R2. We can see in the figure also. So after applying the Pythagorean theorem, we will get the relation between the height, slant height and the radii of the frustum. Please note it down. Make sure that you are noting down every formula and how to derive them. So Chem, let's summarize our class. So in this class, we have seen that we can find the volume of frustum if we know the height and both the radii of the frustum. We can find the CSA and TSA if we know the slant height and both the radii of the frustum, and we know the relation between the slant height and the radii of the frustum also. Now champ, don't forget to practice this formula from your books and make sure that you are solving the previous year questions also. Champ, that's all for this class. Don't forget to practice. Stay tuned and keep smiling. Bye-bye.